Um, well, hello class. Happy Sunday for those of you that are watching today. This is being recorded September 16th, sorry, September 17th, Sunday. Um, as mentioned in our course overview, I will be creating a number of video recordings that complement our in-time sessions during the studio to essentially introduce you and walk you through a number of technical topics. And the first technical topic that will be issued today is to talk about parametric and performance-based modeling. So as a very high-level reminder, Rob and I had this idea, hypothesis, if you will, that generative landscapes are actually composed of three core technologies in order to achieve better performing objectives, perhaps balancing competing interests, and to delight occupants by essentially augmenting your work. And we propose doing this through these three core technologies. As a high-level reminder, they are real-time rendering, which you've already been having fun with and experiencing through Twinmotion and virtual reality, artificial intelligence, three subtopics there, and parametric and performance-based modeling. And as you have experienced during class on Friday, you would have seen that we already started to introduce you to this logic of two main elements to get out of parametric and performance-based modeling: generators and evaluators. I'm not going to go into deep detail on each of these here, but I will say that today we are just focusing, or this video rather, is just focusing on parametric and performance-based modeling. So at the very beginning of the course, we indicated that in order to achieve this capability of parametric and performance-based modeling, we're going to rely on a series of tools, tools meaning software, that basically will help enable you for conducting specific to landscape architecture tasks. And so at the very beginning, or the left here on this slide, we are relying on the geometric kernel. This just means whatever you can do in Rhinoceros geometrically is the limitation of what we can do. And in order to access some parametric control, we're going to be doing this through visual programming or visual scripting. And that is enabled through essentially a plugin which is now standard in Rhinoceros called Grasshopper. More specifically, we will be accessing some additional capabilities which are not out of the box in Rhino or Grasshopper, more specific to some landscape modeling requirements. And for that, we're going to use LandKit Pro. We may also leverage some plant library and details with Lance Design, and you will notice we will go through many additional plugins as needed. So we're going to go nice and slow because I know some of you are have some experience and some of you are just getting into this. So we're gonna start from very basic levels and just get some level set as this slide indicates here. This is basically just telling you what I'm going to go through in this particular video. We're going to go very base level. What is Rhino? What is Grasshopper? Just some reorientation, just level setting on some simple things. We'll talk about landscape surface geometries, just as an overview, because I know this came up a couple times in class with questions during class 1, which was great. I love that you guys are getting really, you're starting to ask some really great questions about differences and similarities. So we're just going to refresh that here. And we'll talk about in the level sets, just getting into some of the elements of Rhino and Grasshopper before we get into LandKit introduction. And we'll do just a very very preliminary introduction to LandKit with a quick overview of TopoKit, which is one of the 4 kits inside of LandKit. And there will be more on this next week when we step into our very first experiment. So let's do a little rhinoceros level set. We'll just talk about history and future, what to expect when you're inside the software and the program itself. And we'll talk about some strengths and things that are unique to Rhino that you would not see in other applications, perhaps such as AutoCAD. So it was interesting to just refresh my own history and take a look that Rhino 3D has a little section of its own history. The URL link is up at the top right. Interesting to know that McNeil and Associates, as the parent company that makes Rhinoceros, started by making accounting software for people working in architecture and engineering in the 80s. And in the mid 80s, there was a time when McNeil was also reselling AutoCAD. And there was a time when, as I mentioned in class, for those of you who were at this section of my little blurb on the history of Rhino, is that there was a strong interest locally, geographically, regionally to Seattle to incorporate a NURBS geometry library into AutoCAD. The reason why, again, as a quick refresh, is that in Seattle, there's a strong boat building industry regionally, and there was a need to make the hulls of the boats using NURBS geometry to accomplish that. It was just easier. And so there was a big demand to incorporate it into AutoCAD. So that very first plugin was called AccuModel. And around the same time, they hired someone else to come in to bring in some mesh capability, so non-NURBS capability into this plugin called Sculptura. So over time, they decided to call this plugin at the time, this special software called Rhinoceros. It was just a code name at the time. And I'm not going to go into too much details after that, but I know within inside of Autodesk, we know one of the reasons that essentially it stopped being a plugin for Rhino is because they started to develop a number of core functionalities like simple CAD drawing, line work, hatching, layers, things that were in a sense directly competing with AutoCAD. And so there was a movement of not being a plugin for AutoCAD anymore. And in the 90s, Rhino went through some rapid development to essentially become a well-established, fully fledged CAD tool, just all on its own. By the time we get to the 2000s, in 2008 is when Grasshopper was first introduced to Rhino for Windows in 2008. And since then, there have been lots of different versions. We're at officially version 7 as a stable release right now. Version 8 is in beta if you want to experiment with it. And new to version 7, which was pretty exciting actually, was the fact that there is now subdivision surface modeling, or called sub-D modeling, and quadrimeshing. And these are just digging deeper into those two base functionalities, working with NURBS and sub-D modeling, working with mesh, and now quadrimesh. So it comes to no surprise that the geometric strengths of Rhino are NURBS. And I would say, if I had to give it a star rating, Rhino would probably, from my experience, sits in a 3 stars out of 3 level for working with NURBS. It's very simple, it's very easy to control, and it's very easy to understand how NURBS are actually created. Now, for those of you who are like, what even the hell is NURBS? NURBS geometry comes in 2 flavors. There's either curves or there's surfaces. They're treated the same, as you can see graphically here on the right. Basically, it's a series of control points as indicated on the upper right image here with green dots, that have a weight on the resultant curve in between. And in a surface capacity, you can see here, again, these points indicated in red have this soft impact on the resultant surface underneath. And this was a profound difference to the way that modeling, CAD geometric modeling was taking place. If you want to read more, there's actually some really great simple overviews on Wikipedia that I would directly point you towards. On the mesh side, which as we know came from that other person coming in at the beginning of Project Rhino called Sculptura, Rhino, in my opinion, as a geometry strength, is kind of like a 2 out of 3 stars, maybe even 1.5 to be quite honest. It's able to work with elements that make up polygonal meshes, and we'll talk more about the underlying components or elements that make up a mesh. But Rhino works decently with vertices or points, the edges that tie those points together, faces that are result, and polygons. These are the base requirements. And again, you can read more at Wikipedia if you like. But really what we're interested in is how these elements come together to make objects, such as surfaces. So again, in the spectrum of other tools, Rhino is kind of like, it's a medium and it's doing both of these things simultaneously, decent, and with a high degree of transparency and accessibility. So the other thing that you'll notice when we're talking about NURBS and we're talking about geometry in Rhino is that you'll notice that when you draw things in Rhino, even a straight line, Rhino will sometimes call this a curve. And you may be wondering, why is it called a curve when it's clearly a straight line? And I have a little GIF here animating how actually Rhinoceros understands lines. They're all curves. They just have different degrees of curvature. So what you're actually looking at in this GIF is actually a first demonstration of using Grasshopper, just some very simple components, points to construct a NURBS curve, and I'm changing the degree of curvature. Degree 1 curvature is a polyline. It's very much a segmented straight line thing. Degree of curvature 2 starts to interpolate those points to create a softer result. And degree 3 and 4 gets even more and more, we can call it smooth or higher degrees of curvature. Now, again, to bring you back to how and why this particular type of geometry was made, taking it back to boat building, here we see a history of Bezier curves, which are similar in a sense. It's basically, in this case, people who were manually drafting boats and planes and even car parts. They would take a piece of balsa wood, physical piece of wood, and they would apply these weights, literally these what look like fishing tackles, to weigh down the balsa curve in order to draw the soft curve that they were looking at. And they needed a process like this that could be repeated. So if I put a piece of wood here and I put a weight here of a particular weighting, it will always create this curvature. And so this became a repeatable mathematical approach to drawing complex curves for objects. Why does this matter to landscape architecture? We will see, maybe up until even just a couple of years ago, a fair degree of what I will call confusion around these two geometry types of NURBS, curves, and surfaces and meshes. And nowhere was this expressed most than in this book Landscape Architecture and Digital Technologies by Jillian Wallace and Heike Rahman, who I have to say, I really love their work and this book in general. But you will see that there is some confusion around the way that these two geometries are described as it relates to landscape architecture. So this is a direct pull from the book. Some of it is accurate and correct, such as NURBS, were there to help for freeform surfaces, such as ships' hulls and car bodies. It's like imagining a rubber sheet that you can pull weights on. There's other ways of describing it as well. But then there are some parts that don't really make a lot of sense. And nowhere is this more evident than in, I forget exactly which page this is, but Jillian Wallace and Heike Rahman are investigating a series of precedent projects that might use different geometries. And they call out these three representations of a park, a hardscaped park. And they describe the geometry on the left as NURBS, the geometry in the middle as mesh, and the geometry on the right as subdivision. No, the one on the left is not a NURBS. It's clearly a mesh. And you probably already kind of intuitively know this by the presence of triangulated faces. This could be just a representation, but the fact that the topology, the underlying structure, is revealed tells me otherwise. The middle one, yes, they got it right. It is a mesh. It's just a very low poly count mesh. And then on the right here, they're calling it a subdivision modeling, which is sort of correct. We don't really know. I would actually perhaps even venture to say that this is a mesh as well. So again, we'll come back to why this matters for landscape architecture, but to delaminate the association with landscape architecture or landscape architects trying to describe it, I would encourage you to go a little deeper into your understanding of this by downloading the Grasshopper primer, which is great for not only Grasshopper introduction kind of orientation. This is also linked now on the Discord, but it also has some amazing underlying geometry descriptions. So there's this section here which tells you what NURBS are and tells you how NURBS surfaces are similar to NURBS curves, how you can understand their local domains, the introduction of U's and V's. Again, these are like X and Y axes relative to an object for convenience purposes. Talk about this in a little more detail. And then to describe what is a mesh. And, in the world of Rhino and Grasshopper, meshes are defined by vertices, edges, and faces, very similar to what we saw at the beginning and on that Wikipedia entry. And you have a lot of control of those pieces, mostly through Grasshopper to access them. But here's a great comparison of how the two geometries behave differently. And as we talked about with NURBS surfaces, you're pulling on points that affect it kind of like a cage that pulls on an underlying surface weighted down slightly differently. So as you can see in this little diagram here on the left, this points in blue are essentially this control cage. And when I pull on a point in the control cage, it has a very soft effect overall the surface. A mesh, on the other hand, out of the box, normally, is treated this way. If I pull on a point in a mesh, it's going to affect the edges that are attached to it and the residual faces that are attached to it to create this very sharp little spike. So the influence of a point that defines a NURB surface can be thought to be more implicit. And on the mesh, it is more explicit. It's more direct. I'm pulling on you and I'm just pulling up a point versus the left. Another way to distinguish NURBS versus mesh, and this is super important for us, is that when you zoom in more and more and more into a NURB surface, the degree of curvature or resolution stays the same because mathematically you basically have the same description of that curve whether you're at a zoomed out scale or a zoomed out scale. You would expect to see no difference. However, in a mesh, again on the right, as you zoom in, you literally see those facets because the geometry is defined explicitly. So meshes inherently can sometimes be lighter in terms of their computational weight versus working with NURBS. And I say sometimes because it depends on the application. But I just really want to call out the difference between these two fundamentally. So when you're thinking about pros and cons between the two, and we're going to talk a lot about these, there are some reasons why meshes are favorable in certain situations or unfavorable. And we can talk about when that may be the case for us. So why does this, again, let's go back. Why does this matter for landscape architecture? Which geometry should you employ and for what reason? And what are the benefits or trade-offs with working one over the other? Now, in this particular course, I may and Rob may prioritize, or we may privilege meshes over NURBS, at least in the application of land forming or constructing a topography. And the reason why is basically listed in green here. Most geometry that digital terrain models or other survey files will come in as point clouds or raster cells, which can mesh directly onto a mesh quad or a mesh triangulation. They're a little easier, maybe even a lot easier to compute analysis on because you have a defined number of faces. There, let's say in a mesh, there's only 100 faces if you had divided it 10 by 10. That is very explicit. You're only calculating things 100 times. But if we remember about our zooming in example, if I did the same analysis on a NURB surface, it may try to keep going deeper and deeper and deeper as a subdivision in that surface. And as a result, analysis could take hours instead of minutes. Meshes are also a very common file type. You can boil everything down into a mesh. SketchUp works with meshes. Autodesk InfraWorks works with meshes. Other terrain modelers, I'll show you one in a second, work with meshes. They just seem to be very, it's like a universal blood donor. All kinds of software can work with it. The other thing that's kind of neat with meshes is that meshes can get hard ridge lines. Again, think about the fact that you can define an edge of a particular subdivision as a very hard line. NURBS will tend to smooth that out. And it's very difficult to overcome creating a seam or wanting to create a seam in a NURBS than other features. And within meshes, you can change your topology. Maybe some of you are not familiar with the term topology, but there's a great section in the Grasshopper primer that describes topology. You can think of it as your underlying structure, your infrastructure of how your vertices are coming together. And you can change it from quads to triangles or mixing them. And it's pretty fun to change these for efficiency purposes or representation purposes. This is an example of a really amazing tool that I used to showcase in the past, and maybe if students have an interest, we can go over it again. It's called World Machine. It basically constructs topographies for use in video games or movies, and has a very similar style of thinking and working. There are a series of generators that create mathematical black and white pixels that then push and pull a mesh. And you can string together generators and other modifiers to create effects like erosion or shading. And maybe we'll work with this just for fun. It's a pretty neat software. But you can make these fantastic looking results, which are used professionally, more in the entertainment industry than in practice. But we're seeing some experimental studios bridge that divide a little bit. So let's take a look at my screen, and we'll just go over some basics of Rhino first to understand and get a level set. So I'm just gonna stop my share for 1 second. And I'm just gonna pause the recording. Okay, apologies for that. I was just changing something here in the background. I'm gonna share my screen again. And here we are inside of Rhino itself. I'm just gonna move this over here to the right in the meantime. So the first thing you'll notice is that Rhino, let me just back out of this because it may look a little more similar to what you guys have, like so. Where if you're here, you have a general overview of the software itself. You have predominantly taking up the majority of your screen is the 4 viewports, top, front, right, and perspective. You can double click on any of these to make it larger or smaller. Purple out of the box, at least color-wise, indicates which viewport is active. And I'm using a 3D mouse in the background. You can tell because a little 3D blue widget appears around the center of my pivot point, and as such, my motions may be a little smooth, or may look a little strange in comparison to your own experience. But interestingly, you can do a number of things with the little pull-down menu here beside the name, where you can change its graphical representation into shaded, rendered, ghosted, all kinds of different view modes. What I did there to start is just make a little box here on the left with the standard tools. A contextual menu pops up as needed. And usually left mouse button indicates that you can grab something. Holding shift plus left mouse button means you can add to the selection. Right mouse button or control indicates that you will deselect something. So nothing major. I'm just going over some basics here. So I'm just going to make my perspective view large. Up here at the top, you have a series of main menus. From each of these, you'll notice something kind of similar when we go into Grasshopper. There are some geometry types like curves, surfaces, subdimensions, solids, meshes, etc. And inside of these, they have basics like point objects, lines, circles, extensions, and then you can start to analyze or do more complex features. This same structure of this menu is what you'll see in Grasshopper later, starting with simples and then going to more complex features. and starting from simple objects and geometry like curves and surfaces all the way to meshes. No big deal here. These are just your menus, but if you don't like working with icons or these nested menus, which are just another way to access tools, you don't have to. You can work with it purely from these menus if it makes more sense for you. Speaking of menus, or rather nested tools, you have what's called here these tool tabs, and they have a name, and you can hover over them and you can click on them. And in some instances, you will see that when I click on one of these, well, they always pop up and show you a subset of tools. And then more importantly, on the left, if you have your main tool tab here open, you will see a series of contextual tools pop up that are complementary to that tool tab. So for example, if I go to standard, this basic set of tools opens up, which kind of gets you started. But you can go more complex when you go to mesh, and you'll see even sub-nested set of tools. Now, for those of you that are still kind of getting used to Rhino, another thing that is interesting is that some of these tools graphically have their icons with a little triangle. And the triangle indicates that you can actually get even more sub-nested set of geometry commands and operations. And you can even tear off that little submenu, and you can have it free floating if you like. Or what you can do is you can actually bring it up here into your main tool tabs if you want. And I can tear it off and I can get rid of it and it can change. So just some orientation if you need. Now, there is also up here, which I have to say is one of my most favorite elements of Rhinoceros in comparison to some of the newer CAD tools like SketchUp or even some of the new Autodesk versions, is that they get rid of this element here called the command line. The command line is just another way of accessing tools and operations. So you can enter a command manually if you know its name and if you know how to change its parameters within the command prompt. So let's review that there are three ways to access commands. You can access commands or functions through the menu up here. So let's just pick one, a circle with a center radius. So I did that up here, curve, circle, center radius, and I can enter a circle and draw its radius out. I could also do that through my curve tools here if I wanted, or even under the standard menu, there's a circle button or icon, and I can press that and it will do exactly the same thing. Or I can type in to my command prompt, even just the first couple letters, and it will start to pop up some suggestions, circle. And it's going to ask me for the center of circle. And we did the same thing 3 different ways. So whichever version is more comfortable for you is the way I would do it. So I'm just going to delete those away. Hopefully this is all very standard stuff, but I really just want to level set on where we are. Other things that you can do to change your interface in terms of working with geometry, I always recommend having the Layers tab pulled up and on the right, sort of in some ways mimicking the way that Photoshop or Adobe Illustrator might be set up. You can activate by clicking beside the actual button itself. Just close that. Which layer you want active. You can change its name by clicking on it. So I'll just rename that test. You can change its color super simply. Sometimes this gets represented on its representation in the viewport, depending on your mode, sometimes not. You can turn it graphically on or off and or lock it. No big deal. I also tend to have my properties tabs. So this is properties generally, rendering, materials, file locations for materials, help, and notifications. I tend to have these, and I privilege having properties because I'll draw again another circle, this time on a different layer. It's a little hard to see with green. I'll just make it black. If I click on this object, a couple things happen. A, its controlling cage that we talked about with that NURBS introduction is accessible, and I can move that cage around if I want to make a mess of it. I can Control Z to bring it back and click it again and have a much softer change here on some of the curve arc segments. But if I click on it, maybe most importantly, is that here I can see that it is in the properties on this layer. The display color of this object in the viewport is by layer. I could also override that with other colors. I can change line type, which is distinguished here, or I could override it. And if you were in a plotting environment, you could print it in a slightly different way. So this is useful because it's handy to just make different objects and see how Rhino reviews those objects in the properties. So you can see here, we can either show the surface or not. We can have isocurve density to show you the kind of underlying cage or not. It can cast shadows or receive shadows. There's all kinds of things that you can do with the properties tab. So I strongly recommend having it open. Okay. So I think at this point, we have covered some of the basics of Rhino and what to do, 3 ways to do commands, some general ways of organizing your overall experience, and just tabbing in and out and getting into different modes if you need to. If you ever wanted to change the way that this viewport is graphically represented, this could be either for personal preference or because perhaps you want to leverage it using some of our AI rendering tools. You would go to Tools, Options, an Options menu would pop up, and you would go, there's Document Properties and Rhino Options. You would go to Rhino Options. The difference, quickly as an aside, document properties only changes what is happening in this particular file. In this case, I haven't even saved this file, so any changes I make here would stay with this file only. And if I make a new file, these properties that I change here do not translate to the next one. However, Rhino options happen to all documents that you may open, all files. So if I want to change the appearance of something, I could have that change for all future versions of Rhino. So for example, if I want my background to not be the standard gray, I can change its color here. Perhaps I want my backgrounds. Let me just change something here. So my widget colors, text, etc. I'm keeping it standard for now, mostly because I just don't want things to look super different from what you guys are doing. And in that regard, here, you can change each of the display modes under View and Display Modes. And you can see here, whenever a change is made, it goes dark blue. And whenever it's standard, it's black. So out of the box here, I've changed a few things. I could restore defaults here to make it exactly the same, But I'm going to keep mine on the same because I just don't want it to change everything back. But what I will do here is I can just show you that I can change it to application settings instead of white background, which looks more gray. I can turn the ground plane on or off. There's all kinds of fun things you can do, but just to show you that that's where it is. So I'll keep it where you can even do some fun things like having a gradient if you like, two different colors. You can have fun with this because AI rendering later will interpret what it sees on your viewport and can use it. And to that effect, maybe I'll just pause on this topic one more time, is that I can turn things like the grid on or off. Maybe you want that, maybe you don't, because it will get picked up by an AI rendering tool. I can show the grid axes like my X and Y. X is red, Y is green. And I can turn off the little world icon, which tells you what orientation you're in. So again, it just is mimicking Y is green, X is red, and usually it's not represented here, but Z is blue. So just some things to think about, some things to play with if you like. I'm going to go back to my objects and change it to a solid color of just white. And I'll go back to my grid and turn on my axes for now. So I'm just going to flip back to our presentation here. And we talked about the viewport and layout. We talked about the command line a little bit. We'll talk about it more. The next thing I want to cover is, and we talked a little bit about settings. So even graphical settings or keyboard settings, anything you want to do, you would go to the tools and options menu, and there you can change things. I want to have a little blurb on aliases. Some of you may be thinking, what are aliases? So we'll go here, and if you have a particular command that you want to do that you repeat a number of times and you want to make a shortcut for it, you have this really great option under Tools and Options. I'll wait for it to pop up. And you'll notice that it is under the Rhino options, which means every time you open up Rhino, it will inherit these aliases. So let's talk about what aliases are. Aliases are another, in the real definition, it's just another term or representation of something for something else. And you can see here when you go into this aliases tab or submenu that you can make an alias and it will do a command, or in sometimes even a command macro. That's what's being defined here. So for me, sometimes I like to change things. So a great example, I use commands that are similar for me from old AutoCAD. So MI, if I type that into the command prompt, it will create mirror. Same thing with TR. I like using TR as a short form for trim. So if I start typing TR into the command line, trim will be the command that it understands. ZE for zoom extents is handy. We talked about soft edited surfaces in class last time. I'll go over that again, but you can do I made this alias called SES, which makes this command macro. And you're probably wondering, like, why are there exclamation points? Why is there apostrophes? Why is there underscores? What's going on here? This is basically the way that Rhino understands its commands. Exclamation point means escape. If I hit the escape key on my keyboard at any time, it's the equivalent of putting in exclamation point, which means in a command, escape all other things that were on the command prior and start fresh. And when you start fresh, here is some things that you want to do. So a space indicates enter. It's like hitting the keyboard, space bar, or the enter key. Underscore means that it's going to receive a command in a language. Rhino comes in like, I think 12 different languages officially. And then the command itself. And then there's another space to enter. Underscore again, I'm giving you a command in English. So that's what these are. And you can make your own. So you can say, hey, I want to make a new one. And what's a good one that we can do here? I think I put in most of the ones I want to do. If we come up with a new one, you can make it. But it's there, and you would put in that formula of like exclamation point, space, underscore, a command in English, and whatever command it is. Now, I'm going to escape that because I really don't want to make a command. But if you want to make a command, pay attention to your command line or your command prompt, because you can copy what you see here and you can put that into your command macro into your aliases. So I think that's all I really wanted to mention when it comes to Rhino. So I'm going to move on ahead and we'll talk about Grasshopper next. So as a level set, we'll talk about visual programming and scripting in general. We'll talk about where Grasshopper came from, its history, and its future. And we'll talk about ways in which this is being leveraged across numerous different tools, even outside of the Rhino ecosystem. So first and foremost, Grasshopper is not a parametric modeling tool. It can do parametric modeling by way of visual programming and scripting. So I want to really delineate these two things. Grasshopper at its core is visual programming and scripting. It's a way to script or to give commands to a computer or a program, and it's doing it by way of visual means. That's what those little boxes, nodes, and wires are. It's a different way of having a human-computer interface to program a computer or a software. You may be saying like, okay, what's an example of programming or scripting to do special operations or commands, especially things like recursive operations? These would be impossible to do manually. What's an example? If you don't know the artist, designer, Mark Forns, he has a practice called The Very Many, and he uses Rhino script. So he's scripting directly to the computer, in this case, by way of Rhinoceros, and he's giving it special commands in a linear text-based format to achieve his results. And these are some of those results. He makes these pretty fantastical structures, tons of installations. And he has one, actually, for those of you that live or visit Mississauga, one of his sculptures is kind of similar to this in Mississauga. If you ever want to go and visit it, you can see what's one of these people has made. It's a little pavilion outside of a park. I'll show it at the end of this example, but made some pretty amazing structures and installations just by getting proficient at making operations that the computer would do in a semi-automated fashion. So the most important thing when we're talking about visual programming or scripting is that it is going to be used in these kind of special purposes to run or execute series of commands serially, one at a time, for automating commands. And the key word here is commands. So again, I'm going to draw your attention to the command line or the command prompt window, um, because Rhino at its heart is a script-based program. It is receiving a number of commands or scripts that will tell it what to do. And I'll just do a small digression here. But if you ever wanted to make your own little macros, which is sort of scripting, you want to combine some commands together or repeat them, you can do that actually in a really fun one. And one that I thought was, it comes up kind of a lot for those of you who might be building a site, especially if you have to fill in houses, perhaps even suburban houses, and you're like, I hate drawing my squares and extruding them and adding a new one. And I had a similar problem building base sites. And so I built for myself a little macro editor, a little macro at the time. You can do that with the macro editor. So a little window pops up and you can enter the same style of commands that we talked about in the alias section and in the command prompt. And you can run this as a little automated thing. Let me just go to Rhino and show you what I mean here. So I'm just going to make my perspective window large. I'm going to get rid of this circle, rid of this box. A typical thing for me to do was to use a rectangle 3-point. So let's say there's a house on an angle, it's this deep, and then I want to extrude that house, you know, I don't know, 5 meters tall. It's a really low, deep house. And let me just change my color here on this layer to something a little more visible. There we go. So not the end of the world, but if you're doing hundreds of houses in a suburban zone that you want to try to model, this can be a real pain. So what you can do is you can bring up the macro editor. And for me, I already nested this on the side. But you can enter a series of commands. I'm just going to expand this here so you can see it all in one shot. And it is exclamation point, stop, whatever Rhino was doing before, enter, execute on canceling all commands, underscore, I'm giving you a command in English, I want rectangle, enter, 3-point, rectangle, enter. I'm entering in these pauses because I want the user to make an input, and pause waits for the user to do something. Then I do a select last, extrude the curve, and pause because I want the user to input this. So what does this look like in reality? I'm just going to nest this back in here because I like to keep some macros running. If I do this and press play, you can see it says, hey, I know you want to make a rectangle, and you already told me it's a 3-point rectangle. What's the starting edge? So I'll do it again, and then it's pausing, it's waiting for me. And when I'm done, it's automatically selecting the last geometry, which was that rectangle, and it's saying, hey, give me a height. So instead of clicking on the rectangle, doing it, selecting last, or maybe there's even shortcuts like box, 3-point, you could do the same thing. Macros could be a fun thing for you guys to experiment with in the world of pure rhinoceros. And it gets you thinking a little bit more in the way that Rhino understands information or commands. So I'm just going to get rid of these and delete them away. Go back to a little presentation here. And let's talk about visual scripting and programming. Visual scripting and programming has been around for actually quite a while. It's, again, just another way for people to do these kinds of scripting operations and coding in a way. But it makes it easier. It's graphical. And there's a little less syntax, specific way of writing the code that you have to worry about. because it's graphically covered. And there's almost all programs, CAD or gaming or whatever it might be, have this kind of option for people to give commands to the program available. So here's an example of Unreal Engine. And Unreal Engine is the kind of pop-up program of Twinmotion for us in our class. And for people who are making video games, they may be doing something similar. Like, I know I have a command here, and I'm going to give it information from something on the left, and I'm going to define it with some speed parameters or something. So I'm just highlighting the fact that professionally, a lot of people have trouble with syntax and coding, and visual programming is a way to get around that. At Autodesk, we have our own visual programming language. We actually have two. We have Dynamo, which is kind of our universal language for architecture, engineering, and construction products like Revit or InfraWorks or Civil 3D. So, if you were to get into an office where they're using a lot of these tools, you may want to get a little more familiar with Dynamo. And of course, we have Rhino and Grasshopper, where it's the same thing. These are basically representative of script chunks or commands, and then you can organize or drive those commands with some of these features, these nodes. And so here's another example of ways of controlling underlying geometry inside of the host program with additional control. Some people want to code from a language that they already know. And Grasshopper works really well with two languages. It works well with Python, and it works well with C#. This may or may not be a thing for any of you, period. But I will talk about in my next video how Python can be a fairly strong language to leverage when we can use a tool like ChatGPT to write code for us. Because I certainly don't know all the syntax requirements of Python, nor do I really care to learn at this point. But I know enough to describe things to a computer to have it write a code chunk for me. We'll talk about that. But hey, for those of you that are interested, visual programming is not going away. It's probably going to stay as a way to interact with the computer. And it's getting brought down to levels of kind of like children and kindergarten level. And while I was at MIT's Media Lab, I was attending a lot of these sessions that they would run to promote the tool called Scratch. And Scratch, if you haven't tried it, it is super fun. You're basically visually programming here on the right. You got these things like motion, events, data, sound even, and you can puzzle piece them together to create effects. And in this case, I was watching kids, probably no older than 11 or 12, starting to make video games using such visual programming. So they didn't know how to write in C++, but they sure knew how to put graphical representations of code together on the right. So this was what they were working with, and this is what the computer was understanding. And kids around 15 and 16 were starting to control robots using Scratch, which was, oh my gosh, very, very mind-blowing. So why scripting for landscape architecture? Generally, there's this trend in technology to go beyond what is out of the box with some of the tools that we use. Either you want to automate something, You want to have additional computational assistance with extended features, or you want to start bringing in things like artificial intelligence. And scripting or visual scripting is a great way for you to do that. And I wanted to just show two examples where visual scripting came into play. So these are two precedents, both from the same lab. It's called P-Rex Lab from Alan Berger at MIT, who basically came up with this particular project called the Pontine Marshes Wetland Machine. I'm not going to go into detail of this project, but if you want, you can read more at prex.mit Pontine Marshes. For those of you not familiar, the Pontine Marshes are a zone just outside of Rome where through the 1920s and 30s fascist era, some major terraforming and landscaping was done to effectively drain the swamps, literally in this case, of Rome, and to get a straight line canal into the sea. And this is the repercussion of that. So a little bit here on the right, you're seeing Rome and Italy kind of along its coast, not the Adriatic coast, the other coast. And you can see this big canal that funnels all the wastewater coming from all these different towns, including Rome, and leaves these wonderfully disgusting plumes of trash and toxins that flood out into the sea. And so the project was to essentially review this territory and review this zone and think about all these different trenches and to redesign how they would outlet through drainage basins before they get into the sea itself. And so here's the intervention. Here's a zoom out of the territory in question. This is where water is going to start going into the sea. And the green is where the intervention is going to take place. What the intervention is essentially a way to position landform and plants together to slow water down enough that it can be cleansed to a certain degree and or trapped to a certain degree by way of combining topographic interventions, holding cells, and plantations. Plants, not plantations. Here's what some of the topography looked like. And in order to construct this topography, there was a requirement to build it using some advanced features that could not be done out of the box with just something like rhinoceros. So some scripting was at play in the background here. Some of it, I believe, was probably some grasshopper. These are just a couple different views. And this is where some of the science came into play of this project, where a number of these features, I'll just show you here, some of these features, these kind of changing geometries, needed to be tested. It wasn't enough to say, theoretically, I think by channeling the water a certain way, it's going to work. In this case, what Alan Berger did is that he actually said, well, no, actually, I want to test what geometries actually work. How are they going to be better or worse at slowing water down and catching plumes of pollution? And so the scripting for this project basically allowed him to control different types of geometries. So this type 1, these kind of breaks, or these kind of long funnely tubes, or these kind of propagated little islands that seem to stop water as a gradient coming in and coming out. Now, ultimately, he chose this last version, which is what you're seeing graphically on the right here. You're seeing representations of water with pollutant getting injected into this and observing how it would actually flow outside of these cells. And the resultant geometry was milled and turned into a physical object. Representations of plants that would help it further encourage slow the water were put here. And these were some graphical tests of how that was actually done. Another project that took this concept further was to imagine it for urban stormwater wetlands for LA and Houston. In this case, again, you can read a lot more at Alan Berger's website for JWAFs, basically looking at different storms and the water that would come as a result, and how you could effectively slow those stormwater runoff down using different types of geometry, in this case, berms, islands, clusters of the previous two, or pinch points, and to be able to see what effect that had on flow. So this was just looking a little deeper into the control cage of the little islands that were designed. Again, kind of in the true NURBS-esque philosophy, this kind of control cage, which made a softer geometry that would change the flow. And here we're just looking at one sample of those islands. And the question was, could you pattern or tile or combine these things together in order to create, again, slowing and cleansing effects from that stormwater? And then looking at physical tests of those geometry types and experimenting physically with how they might behave when you introduce pollutant. So just some more representations of this. And then the overall incorporation of here, it's pretty low res, I apologize for this, but a little intervention in Houston called the Buffalo Bayou. I worked on this project a little bit, and how an intervention should be included. And eventually this was presented in 2016 to the White House in a commitments to action on building a sustainable water future. So let's take a quick pause here and zoom all the way back out. So we talked about why what Grasshopper is, which is scripting. Scripting you can experiment with on your own ways in Rhino and other means, and how scripting is useful for landscape architecture, especially if you need to make different geometry types, like in the case of Alan Berger, in order to then test or validate it literally downstream in the case of his two projects. And let's go back and just say, okay, where did Grasshopper even come from? Because we talked about Rhino, and how does Grasshopper fit into this picture? So Grasshopper, if we recall, was made in 2008. It was made by this man, David Rutten, who was a designer in England who wanted to get a little more control behind some functionality in Rhino. And for those of you who were with us on day one and listening to my part one in the morning, is that it was basically made as a way, which is validated here, to get beyond the history function and feature of Rhino, allowing a designer to go multiple pieces of history back and controlling what the geometry would be like afterwards. The very first version of Grasshopper was called Explicit History. Because of that, you can see when you open up Grasshopper, it basically is organized into a graph, which was meant to be the multiple steps of history deep that you could go. And it has a graph going downward, basically indicating how many commands or script interventions a designer wanted to make at that step of history. That's why it was originally called Explicit History. The reason that it's called Grasshopper, or so be told, is that the fact that you could jump over multiple layers of history deep if you needed to, because it was just growing in functionality, and the author realized that this was more than just a historical function or intervention. It was going much deeper. So that speaks to the history of Grasshopper. Where is its future going? Last year, around springtime, Grasshopper 2.0, 2.0 alpha was announced. And this was a pretty significant moment for those people working on Grasshopper, because not only does the user interface change dramatically, it's a lot more clean, you can access things very differently. But beyond that is that it is written not in Python or in Python segments anymore. It's written, I believe, almost exclusively in either C++ or C#, which means all the plugins that have been made or add-ons for Grasshopper up to this date probably will not work in the new version of Grasshopper. And that's something that's being discussed and debated quite a bit, because a huge community of extensions was made. And people are really worried that all these great tools may not be available anymore. So I just want to put that on your radar that, hey, this is potentially coming. And all the plugins and tools you may be working with may be called into question. But for now, we will continue proceeding with Grasshopper 1, which is part of Rhino 7. The last thing to mention in regards to the future of scripting and Rhino in general with Grasshopper is that it's getting to be a lot more pervasive in the industry than originally thought. So up until a couple of years ago, you were either a Dynamo person doing things inside of Revit and Dynamo, or you were a Rhino and Grasshopper person. And offices used to have two sets of expertise that they would build up just to do these two separate programs. And it was super long, and it would take a long time to build that dexterity, and things were not always transferable if you needed to. As of last year, officially, a new functionality from McNeil came out called Rhino Inside. And Rhino Inside is, as it sounds, it's the ability to put Rhinoceros inside of another software, which sounds kind of crazy, but a really super strategically smart move on McNeil and Associates, because it basically allows a little bubble of Rhino to stand inside of a host software, and then you can access things like Grasshopper and then push everything back down to the host. So the most popular example is Rhino inside Revit, which basically, as you're seeing here on the left, allows you to control a Revit model using Grasshopper. So for those of you that are looking at getting into offices that need to use Revit for documentation or BIM elements, you can now directly transfer what you're learning in this class to those offices by way of leveraging Rhino Inside. And I have to say, this was personally like an amazing moment for me, but also for a lot of people that I know work in AEC industry in general, because for years there was this rift between Autodesk and Rhino. And again, you were either a Revit guy or a Revit girl, or a BIM guy or BIM girl, or a Rhino Grasshopper kind of person. And basically what this did is that it started to stitch those two communities together. And it was officially announced at Autodesk University. I saw the Rhino crew last year at the event we had in New Orleans, and it was talked about on main stage. So the CEO and the main representative of our AEC collection, Amy Bunzel, was basically just talking about Rhino and Grasshopper openly for the first time ever in Autodesk history. So I'm highlighting this because I just want to reinforce the fact that we are entering a very different world as of last year, where you can directly transfer your skills to a number of different products, and many of which you may see professionally. So let's do a level set inside of Grasshopper. And I'm just gonna pause for a second here, just to take a small break. Okay, so we're gonna level set here on Grasshopper. Similarly to what I did with Rhino, I just want to do an overview of what is inside of Grasshopper, its canvas. We'll do some simple navigation, and we'll talk about talking with Rhino, or how things go back and forth between the two applications. So first things first, I'm just gonna open up my basic view here. Grasshopper is in the standard toolbar to start. Again, if you want to access a command, you do so by either clicking on an icon or typing it. In this case, Grasshopper, I'm typing it, and a window pops up. Now for me, I already preloaded it, so sometimes you'll see a little green box appear with a loading bar, and that's fine. If you're noticing what the difference is, don't worry. But let's just go over what happens, because a little window appears, and it kind of takes up some of the way that your viewport might look, and this can get annoying, and it's personal preference how you want to organize Grasshopper and Rhino together. There's two ways to do it. Number one, which is probably the most popular way, and you will see me do this 95% of the time, is that I will make Rhino move over to one side of my screen. For those of you on Windows, you can dock it this way. And I will make Grasshopper go to the other side. And so I'm having these two things side by side because one will impact the other one. One is literally talking to the other one. Now, I tend to sometimes flip between Grasshopper on the right, Rhino on the left, or vice versa. It's totally up to you how you want to do it. This can change periodically for me, so don't mind if you see me change this. But I do prefer to have them standing side by side like so. Now, if you don't like that, what you can do is you can make Rhino full view, and on the Grasshopper tab, that window tab that pops up, you can double click it and it will hide it or minimize it. So you can do whatever you want to do in Grasshopper here, and then you can make the change, and then you can double click it to hide it away. Both options, totally fine. Do whatever you prefer. I'll leave mine this way for now. So let's talk about what you see when you open up Grasshopper. The very first thing you'll notice when you have a new document is that graph. So going from left to right, how many steps of history do you go deep? And graphically downward, how many operations do you want to add? The graph is there as a historical legacy. It's only there graphically speaking. It does not actually organize data this way anymore, but that's what it looks like. And this is what we call the canvas. This is where you put down a series of visual scripting nodes or components that effectively emulate a command from the command line, and you are interacting with it in this canvas, and you get to string them together in different ways. So the canvas itself, there's nothing really special about it. It has a kind of infinite space that you can eventually work with, and it gives you a little starting corner to begin with out of the box. Now, up at the top, you have a file, an overarching menu bar here. So file, you can open a new document, save one. You can get to special folders. We'll talk about that in a second. Preferences overall, like you can name scripts a particular way. You can change the display of things like fonts, overall interface, color palettes for things like how things on the canvas will look. The viewport, which changes things in Rhino, and widgets, which we'll talk about in a second as well as how you want to organize files and the overall solver under the hood. So I won't touch too much of this. I'm going to leave this on its own. Edit, honestly, you'll probably never use edit that much. You're going to probably do a lot of the shortcut commands like undo, redo, cut, copy, paste, etc., just through the keyboard. View, on the other hand, this you probably do want to make some modifications if you want. I like to keep on my ribbon tab icons. So you can see here, this thing here is called the ribbon tab, and it can be represented in two ways, either by letters or by icons. I prefer icons because I somewhat remember what the tool set is inside of each of these. Canvas toolbar, that removed this piece here. And that just allows you to do some quick things like open, save. You can make a little sketch if you need to on the fly. You can delete it. You can change things like how the preview will look in Rhino over here. It's just, you know, another way to do things. I do keep it on because I do use it. And then components tabs. Now, if you didn't have components tabs on, you could probably do very little, but this is where most of the stuff is. It's called your components tabs, which are nested inside of these ribbons, this ribbon tab. So as you click on each of these, different components show up. Now, for me, I have a ton of additional ones. For some of you, you may be stopping here on the little eyeball, or you may have a word that says display. That's fine. Don't worry. All of these other ones you may get to and you may not to. I use some of these professionally or for teaching, and so I have a number of them listed here. But these are organized very similar to what we did in Rhino, where you could say, hey, I want to work with a curve, and that's similar to curve here, where you have some objects to begin with, simple things, and it gets more complex as you go. Guess what? Super similar in Grasshopper. It starts with analysis, usually some more analysis if you need to, primitive objects that would define curves, more complex versions, and then additional utilities. And these are the same. You'll see curve, surface, and mesh. Curve, surface, sub-D and solid are derivatives of surface and mesh, and then mesh. And they're kind of the same way. They always go the same way, which is you have some analysis at the beginning, a bundle of components, some primitives, and then some advanced utilities. Same with mesh. Analyze it, do some primitives, maybe refine it, and add some additional utilities. That's how almost all of these are organized, even people that make additional tools. Here's an example from LandKit, TopoKit that we'll talk about. Create those primitives. Here it's reorganized a little bit where analysis is done on the right, but then there's some advanced features like drawing on the far right. Most authors of plugins do it this way. So that is a super quick overview of what Grasshopper looks like in terms of these view components. You can do things like you can view, let me just go here, display under view. Obscure components shows you everything. Out of the box, you will probably see these, but if you're like, oh, you know what, I really can't find a particular component, put in this and it shows you all of those components if you want. The next tab is display. I always put in draw icons. I always draw fancy wires, and I draw full names. You're probably wondering, for those of you that are new, what is this guy even talking about? Let's do a quick example here where we're going to bring in a primitive of an object. I'm going to make a primitive sphere. So I'm going into the tab here. I'm going into a primitive and I'm going to make a sphere. So that's what's happened here. Now, the only thing that's different inside of our Rhino viewport is that a sphere has now been drawn. So here's that sphere. So the reason that I wanted to show you this quick little example is because a few things can happen here back to our display. I can draw full names on or off, and you can see here that now these input nodes are reduced down to one letter as my output. So I like to keep draw full names on because it's more explicit what it's asking. I can draw icons. I prefer drawing icons because graphically it's a little easier to remember things, although some people do leave the name on because the name is more explicit. So I draw icons. And I leave shaded preview on, which previews it here in Rhino. The last thing that I want to mention here is canvas widgets. Canvas widgets, a lot of them come out of the box turned on. The exception is Profiler, which is not turned on. You can turn a bunch of these on and off. Compass, as you saw down in the far right, basically just allows you to see where your nodes are. If you don't want to have that on, you can turn it off. Align is basically a way of, if I had two, I just did a Control-C, Control-V here. If I have two spheres and I have them moved around separate, I could select curve, a crossing window of both of these, and you see these little icons here up at the top and the left around this little box. They allow you to align these nodes graphically in your canvas. It's a simple way to keep things clean. Some people like it, some people don't. I like it. I like to keep stuff super clean. Speaking of super clean, there is another feature that I have turned on, an add-on for Grasshopper called Snapping Gecko. For some of you, you may stop, your menu will stop here at help. You will not have MetaHopper or Snapping Gecko. Snapping Gecko is handy because, as you can see, as I get close to an object, little guide rails pop up, these little green lines, and they kind of snap or make the component sticky on my mouse, which allows me to align it without having to use align. Just another way to do it. If you're interested in getting Snapping Gecko, I'll talk about that in 1 second, which is how to get plugins or add-ons. So I'm just going to delete that and keep my single sphere on. And we've gone through display. Solution, we're going to keep everything there the same. And help, you can go through tutorial files, Grasshopper support, etc. So I'm just going to delete this away here, and you can see that that has stopped. And I'm just going to go back to my component here. Oh yeah, so some navigation, left button, mouse, right mouse button, left mouse button, and talking with Rhino. Oops, let's go back here. So left mouse button. Basically, when you do a left mouse button on its own, single click, nothing happens. When you double click, this little enter a search keyword appears. This behaves very similar to the command prompt inside of Rhino. So again, double click left mouse button, and I can start typing in sphere. Let's just go for that. And you can see here, I type in the first 3 letters and something appears. The component has effectively been populated here, which is great. Instead of me going to the ribbon and the components, it's just a shortcut. I use this shortcut to get components a lot. Sometimes I will go into a nested toolbar to find out what it is because I have forgotten the name. But for basic geometric components, I tend to always do the keyword search. Since we're on the keyword search and we're working with a sphere, let's do something here where we actually work with something inside of Rhino. Now, when you're looking at a component on its own, you can hover over any of the names to see what it is looking for to define this object. And this is where some parametric control comes into play. You can control this sphere with a parameter. And you can hover over the right to see what is going to come out. So there's these input nodes, these little graphical representations here, and an output node. And this is the way most components work. Something goes in, something happens, something comes out. They always go from left to right. The data flow inside of Grasshopper is uniform. Things always progress from left to right. This has an impact on all other tools that are made. So let's go here with something. We can see that when we place this object down, it's gray. The graphical representation of this node is gray. When I left mouse button click on it, it turns green, and it is mirrored green inside of my Rhino viewport. If I click off, it turns red, which means it's not selected. If some of you want to change this, you can go to Display, Preview Settings, and you can change the way that this looks. Perhaps some of you find red and green annoying. Maybe you want to change a color. You can do the normal geometry when it's unselected. In this case, it's kind of a shady red versus a shady green. You can change that if you want. I'm going to keep mine the same because I just want to keep things a little more standard to start. Now, if I wanted to move this sphere, I could effectively do that. What does it need? It needs a base plane. So I love to work this way, which is I start with something I think I want. I want to make a sphere, and then I see what it needs. So in this case, it's giving you a clue. It's even giving you a drawing of a little hexagonal icon with a plane on it. And it's saying, hey, I'm using, out of the box, the world XY plane. So flat XY plane. I could also tilt a plane up on some other level, and I can define planes in any which way I want. But out of the box, sphere is asking for, it has a base, which is XY. I can double click this and hit plane. I want to, in some way, construct a plane. So here's the difference now between a component, which takes an input, it does something, it makes something, versus a parameter. A parameter, which is the very first tab, is basically these things that hold on to data. They are containers of information. They hold things that then you can push into something else. This is also a great moment to distinguish the difference between a gray component or a node and an orange node. I use the term node interchangeably between components and parameters sometimes. In this case, both of these are nodes. They're both graphical node representations of a piece of script. One of them is orange. Here, a little bubble appears and it says, hey, it's orange because it's undefined or not well defined. In this case, it's giving you this little pop-up error message and it says, hey, this floating parameter of plane, it didn't collect any data. So if I tried to give, and I'm holding left mouse button on the output node or knob here, and I feed that to the base. So I wanted this plane to feed and drive this sphere. Now it says, hey, I don't have a base. So we may need to define this plane in a better way. And the way that we can do that is we can go to our vector tab, and inside of our vector tab, there are planes. And it's a very primitive type of geometry. I want to construct a plane. I want to make a plane that I can move around. So I'm going to call on construct plane, which says, I have an origin, a point, and I can define things by an x-axis and a y-axis. So I'm going to put this into here, and you can see now that this origin, this was the same as before, is being referenced from this origin, which if I hover over it, is at point. You can see here the origin of the plane is 0, 0, 0. Great. What if I wanted to move that point? I can right-click on any of these inputs, and I can say, hey, I want to change this point from whatever it is to something else. So right-clicking on top of these gives you under the hood access. So out of the box, it tells you it's 0, 0, 0. I can make a point, and I will make a point here under parameters. The very first one is a point container, little X representation, and I'm going to feed it into this origin. Now here it says, hey, I don't have a point. I'm empty. And I can draw. I'm going to draw a point under my layer 1. I'm going to draw a point. There it is. And I'm going to right-click on this point container, and I'm going to say set 1 point. And now you can see in Rhino, the command prompt has popped up and says, hey, what point do you want me to reference? So it's waiting. It's in that pause mode that we talked about with the macro editor. So I can now click on this point, and now this point is changing my origin, which is making my base plane, which is changing the point of my sphere. So now I can move this point around. I'm just going to move up and make sure that my gumball is turned on, because I want to move that point in the XY plane. And now wherever I move that graphical geometry point under layer 1, it will use that as the origin for my plane container, and my base. So hopefully this gives you a super tiny view of some of these things, how I can string together. I want to start from a sphere and I want to have it talk to Rhino. I want to use something from Rhino here. Now, I don't have to do this. This is a way that I control it inside of Rhino if I want. This is what we call volatile data. It sounds more destructive than it is, but basically, if I open up a different Rhino file that does not have this point and is not referenced by set1point, this little script here will fail because it doesn't have that piece of geometry. And so it's when you're opening files and you're correlating Rhino geometry to Grasshopper scripting, you want to make sure that these interrelationships, you're aware of them, because you may open up files sometimes and things look like they're broken. They may have lots of orange or even red icons, which basically mean, hey, I'm not working for whatever reason. And that could be a significant problem. Here, for example, nothing is defining this mesh. And as a result, it's orange and nothing's being made. So just be conscious of volatile data dependencies between Rhino and Grasshopper. I could define this sphere a different way. I'm going to disconnect this data from the output knob to the input knob here by holding on to Control on my keyboard, and you can see a little red arrow icon, and I can disconnect it. I can also right-click on things, and if it was connected, I could say disconnect you from the point, and it will disconnect it. I could make the origin of this truly parametric by constructing a point and using that as my origin. So let's just try that. I'm going to go here and I want to construct a point through an X, a Y, and a Z coordinate. This will make a point, and that point will become my origin. That origin will be used to construct a plane, which will be used to make my sphere. Now, to define my X, if I hover over it, it's got a 0, and a 0. It's just making a point at point 0, 0, 0. I could change this by manually typing in a value. // pops up a panel. We'll talk about panels importantly in a second. But I can double click in a panel and give it a value. Let's say 1. And I'm going to click outside of it, not enter, clicking outside of it. I could use this panel, which is holding on to the value of 1, and feed it into X. And you can see here that when I do that, it shifts the X coordinate of that base plane over by 1 unit. I am highlighting 1 unit. Units in Grasshopper are inherited by Rhino. So if I am in Tools and Options, if you recall, I'm in my Document Properties, things that affect this file only. Units, in this case, is in meters, with a tolerance down to 2 decimal places, which gives me 1 centimeter of precision. And I have an angle tolerance of 1 degree. Perfect. This means that this has moved the center of this sphere over by 1 meter. Now, I could copy this many times over and just continue to add it. And I could work with things in this particular way, where I now have a sphere going up 1 unit in the Z, 1 in the Y, and 1 in the X. And I could come in here and say, you know what, I want it to be 8. And it's going to move it 8 over. Now I have some parametric control over the creation of this sphere by going and modifying a point only inside of Grasshopper. If I open this Grasshopper file up, regardless of the Rhino file, it will work because everything is made embedded inside of this file. Now, some of you know this quite well. Some elements you don't want to do by double-clicking and changing values. Sometimes you want a little more of a smooth interface. And the most classic way to enter values in Grasshopper is with a slider. The short form for slider inside of Grasshopper is double-clicking, starting with a number, and you can see a number slider appears. And I can make it have a decimal value of 1 spot, which would give me 10 centimeters resolution. And I'm going to say start with, well, maybe I'll start with 0.0 because I do want to start there. And allow me to go to 10 units. And this will give me now a slider that if I plug into here, you can see it is pushing that base origin plane and then moving it over. Now, if I don't like what I made, I don't like going from 0 to 10, I can double click on the name number slider, and let's just call this X. It's going to change it there. I can change my number from being a floating point number or a number with a decimal value, an integer, even numbers only, or odd numbers only. I'm going to keep it at a floating point with 2 decimal values. And here I can double click on my numeric domain, the start and the end. And I want to go from -10 to 10. This is now the range of values. It can go from -10 to +10, and it has a range of 20 values. And my current number, I'll set it here. So now my X value can go here to here to here. And I'm going to copy this and turn these into my X, Y, and Z values. This one, I can double click on it. This one, I want it to stay at 0. And this one here, I'm just going to rename it Y. And this one, rename it Z. So now I can move around this point any which way I like, and it will make the sphere driving this plane to make the sphere that I want. Now, another great aspect here to highlight the functionality of a slider is the radius. You'll notice that as a default, the sphere component makes my sphere with a radius, not a diameter, radius. That's half of the diameter circled around as 1. And I want to change that value from 0. We're going to purposely break Grasshopper here to go from 0 to 5. I'll match it at like 1.3 radius for now. And you can see it has grown a little bit, and it will grow bigger as the radius increases. But if I go to 0, oh, I wanted to break it and it didn't work. Let me try going with the negative value. Oh, wow. I wanted to break Grasshopper and it didn't work. Basically, what I wanted to happen is to give it a negative value, which this would have been like, hey, you can't give me a negative value. Clearly, what has happened here is Grasshopper has fixed giving any value to this, and it is going to always turn it into a positive value regardless. Okay, for us, this doesn't matter. Let's bring this down from 0.1 meters to 5 meters, and we'll just hit OK. And there's the little sphere going into the big sphere that I can parametrically control its position. So if I were to share this with you, some of you may be saying, you know what, I can't really tell what some of these components are. I guess I could hover over it and you could see construct point and you can kind of tell maybe where to find it. Or I could hover over this and see construct plane, but it can get very easy to get lost with components when they're named just by their graphic. This is where I strongly encourage all of you to get the component or the plugin called bifocals. Bifocals, little glasses icon here, when it is active, it allows you to see both the graphic representation of the component and its name, so that you can easily start to associate these two things together. If I take it away, you'll see that those disappear. I love to keep bifocals on. And you'll notice it's a special component. It basically has this little ragged edge, like it's been torn off, because nothing happens on the outside of this. Just some exceptions can be defined. And you would enter those exceptions with, as you can highlight over, a text value. We're not going to go into this. You'll also notice a special tab here when it's pulled out that a mode is active for this component. And I can right-click on this mode to say active or inactive by double-clicking it. Double left mouse button clicking it. I'm going to leave it on active. Now, some of you who don't already have bifocals may be asking yourself, how do I get bifocals? Bifocals does not come out of the box with Grasshopper. You need to add it onto Grasshopper. And there are two ways of adding things onto Grasshopper. The first is coming into your command prompt and typing in Package Manager. Package Manager is a way to search the web for those who have made additional tools visible to Rhino and Grasshopper, where you can look for online tools such as bifocals. Now, in this case, bifocals is not available. This is some weird situation here where this multilingual GH is made. But you could look up other ones like LandKit. And LandKit can be found here, and you could click on it and install it, and it would do it. This is one way of adding things onto Grasshopper. The other way is to go to the website called Food for Rhino, food4rhino.com. And in here, this is a collection, a public, like a library of different tools that you can gather that you can add onto Grasshopper. So I'm going to type in bifocals into the search, and I will see here bifocals is available. And I will click on it. And for those of you that do not already have a license or an account with Food for Rhino, you would need to create a login. I'm already logged in here. You can tell by my name, and I can click on my name just to see things about my accounts, my Gmail, etc. But the reason that you need an account or to become a member is that you can download these tools. So I would type in bifocals. And these are made by people. So the integrity of these tools changes a lot. It may be an important thing to know this in some cases or not. But once you download it, usually there's some instructions on what to do, and there's different versions that are available for download. You can download it. In some cases, it's an installer, like a .exe or a .msi, and it will install it. And in some cases, you will download a .gha file. Let's just take a look at the fact that the latest version of bifocals is not through the installer. It was from a GHA file. So you could download this, and in here you could basically see that, hey, I have now bifocals in my downloads folder. And you can basically, let's pull this here, you can drag this GHA file directly into your Rhino viewport or your Grasshopper canvas viewport, and it should install it automatically. If for whatever reason it does not do that, you may have to come to Files, Special Folders, Components folders, and here you can see all the additional things that you want to put on. Now, in some cases, either through Package Manager or through downloading and throwing things into the canvas, it is highly encouraged that you restart your Grasshopper and your Rhino. Just shut them all down, save whatever you need to save, start it back up again, and you should see now the component pop up. In this case, bifocals is inside of the parameters ribbon under the utilities component cluster, and it usually becomes the first one because it's pretty useful. So the last thing I'm going to mention here before a little break is graphic representation again of your script. Now you can see here sometimes that lines will go under and over other components, and this can get messy. Imagine later down the line, lots of components and strings going everywhere. This is where it may be handy to introduce a relay into the graphic representation of your script. In the case here, I want to make this look a little neater and not have this line intersect with this component. I can double click on the wire or the line between the radius nub and the number slider nub anywhere in the middle, and it will make a relay, which basically just takes the data and puts it through another pit stop, which can then be graphically pulled over and fed back in. It doesn't change the data at all. Nothing fundamental changes. It's just a way to organize your information a little better if you need it. I tend to use relays a lot. That's what this is. So I think at this point, we've covered the extreme basics of how data flows from left to right. In this case, I wanted a sphere and I wanted to parametrically control it. So I made a plane. I constructed a plane which could be constructed by a point that is parametrically driven or volatilely driven through the point from before. And I'm changing its radius. The last thing to mention here in this very basic setup is if you open up a script and you're like, oh, this is cool. Where did you get sphere? And you're like, man, I've been digging through all of these things and I can't find sphere. I'm getting kind of frustrated. Or I'm typing it and I really can't find it. I don't know where it is. If you hover over your component in question and you hold Control, Alt, and you left mouse button click, Grasshopper will find where that component came from. And as you can see here, it has a red arrow that says, hey, it's in this ribbon tab, and it's in this cluster of components. And that would help you then find the sphere again. So I think at this point, I'm going to take a mini pause and we're going to get into another example um, just to delineate some differences of what you see in Grasshopper to start with. So I'll be back in 1 second. All right, and we're back. So before moving on, the next thing that I wanted to show here is, when you start getting a few things on your screen, on your canvas, they're automatically always turned on as a preview in Rhino. And this can get kind of messy because sometimes you're seeing multiple things happen at once and you're like, I'm confused. So there are ways in which to visually organize things. And one of the things that you can do is that when you click on an object, a component, you can right click on it and you can get some things to happen here, such as renaming it, turning its preview on or off, enabling it, baking it out, what kind of wire display is connected to it, and the ability to treat data coming in or out differently. You can also get a little help here, which tells you more about the actual component in question. Now, in our sake, you can see when I hover over this plane, it highlights this little green grid under here. And I don't really need that for my graphic representation. So I could right click on it and turn the preview off, construct plane, I'll do the same. And now all I see is the sphere, which is maybe what I want. Now I could do that for multiples of them, but not by only right-clicking one of them. When working with multiples, you want to use your middle mouse button, which pops up this special context menu, which allows you to do a few things at once. You can disable things collectively as a group, disable the preview with the blindfold icon, or enable it. So in this case, I'll enable both of them again, or disable them. Or I could bake things out or navigate to them if you need be. So in this case, I want to turn everything except for the sphere off. And we can see all that's left here is the sphere in question. Now, these things are still being calculated. Just because they're graphically turned off does not mean that they are inactive or enabled. It just means that they are graphically turned off. And that could help you in the way that you do things. So I'll just call that out, that middle mouse button is pretty handy for a lot of stuff that you may be working on. Also here, you can be like, hey, I want to zoom to this geometry in my Rhino viewport, and it'll do so. So if you're kind of stuck out here and you're like, oh my God, where even is this sphere? This will help you bring you back to that point. Okay, let's do something a little more ambitious. I'm gonna disable these. There's really no reason to keep them on at this point. And you can see that they turn dark gray with orange lines because there's no data flowing between these nodes. They're effectively turned off. This is handy when doing sketches of scripting and you're like, that idea, I'm just gonna leave it for a while. It saves computational power. And we're gonna start a new little test here. Some of you were really interested in making a surface in a slightly different way in class on last Monday. So I'm going to go ahead and do that. My layer 2, I'm just going to call this a surface. I'm going to make a surface starting from 0, starting from 0, 0. And I'll make it 50 meters by 50 meters. So here is my surface. And I want to reference this surface into Grasshopper. So we talked about that, where you can bring it into a parameter or a parameter, which is a container of data. So I could find that here within my parameters geometry. I would go and find a surface container, and I could right click on it and say set one surface. There it is. And I could turn that preview layer of my Rhino file off. I don't really need it anymore. I already drew it, and I don't need to see it anymore. Now, I could always move it around, and it would update, and I could still turn it off. I'll leave it at the origin point for now, which is back there, and I'll have it turned off just so that we can see it a little bit better. Now, in this case, I want to not have this preview on. I'm just going to turn it off. And I want to rebuild this surface because right now I can't do much with it. It's like a sheet of paper, and I want to be able to change that. So the way that I can do that, as I was demonstrating in class, is that I could use the command called soft edit surface. And for me, my shortcut or my alias is SES. That does the same thing as soft edit surface. Now in here, it says, what's your base point? What point do you want to use? And what degree of influence will it have? How many subdivisions of U and subdivisions of V do you want me to influence? Now, I'll start off by clicking on this and saying, maybe 5 degrees of influence in each direction. And as I click on it, you're like, whoa, that's huge. It's a huge degree of influence. What happened here? That's because the base underlying UV structure of a surface is always 1 and 1. It's only divided up one time. So if I wanted a finer degree of control over that surface, I would need to rebuild it. And I type in the command rebuild. Rebuild surface says, great, you want to remake me with a different U and a different V count. Go ahead and do that. In this case, I indicated 40. I could make it 50 and 50. I'm keeping it even to start with just for now. And I could say what degree of curvature. Remember back to the Bezier curve with the balsa wood? That's just how much influence will the cage of points influence the surface. I'll call it 50 and 50. I'll delete the input layer, which means I don't want a copy of it. I just want the new one. I'm going to keep it on the current layer, yes, and I'll retrim it in case I need to. So here it is now, redrawn. It's now on the red layer because it's been moved to that one. I could undo that and just rebuild again and not bother keeping it on current layer, but it's origin layer, surface, not red. And we could see here what has happened. It has made more UVs, which are those cage points in the presentation that I shared. So now if I do SES and I have a point, I can lift it up by influencing 5 UVs in one direction in the U and 5 in the Y. I want this to be a little more, so I'm going to go 20. And you can see here, you can make these very interesting humps if you wanted to. Perhaps they're berms. So I'll do that. I'll do it again. And you can see this strange effect that we get here. Now, what's happened is that it's turned red because I had a surface that was put on from before. So I'm just going to, oh, it made a copy. Let me reverse this for 1 second. I'm going to do SES. And what happened is that it made a copy for me. So I'm going to turn the copy off, and I'll do it again, where it's now doing these effects here. And when I'm done, I'll just hit enter. And I get these kind of interesting effects here. And I can just go back and turn the preview on here to make sure that Grasshopper is still reading it. It is. And there is my surface by itself. Now, it doesn't look like much because a surface is represented as a sheet of paper. There's no subdivisions in it, so it can actually be kind of hard to see this object. You see here, I can only tell what's really going on when I hover around it. So, sometimes it may be handy to leave this on, sometimes not. I'm going to show you a way to visualize your surface in a different manner. One of the things we can do to override the basic green and red is to type in custom preview. Custom preview says, give me a geometry, define a material, and I will change the way that it looks on your preview. That's great. That's kind of what we want to do. I don't want to see it in green. I want to see it looking a little differently. So I'm going to take this surface and put it into geometry. And as a default material, you get this classic bubblegum pink that Grasshopper has decided to use. Arguably no better. So what we can do is we can change this by making a swatch, a color swatch, and we could feed that into the material. And I could change this color material now any which way I like. And you can see I'm having some fun here just with some shades of red. Maybe I want it to be a little more earthy green. We'll leave it that way. And you can see it's still a little hard to tell what's going on because there's no shine on this material. Now I could go to wireframe and I can see it a little differently here. So I do want to call out that your different modes will change the way that you see geometry here. I could go ghosted, wireframe. My shaded preview does not carry that. Tools, options, view, display modes, shaded. You can see that when I go into shaded objects, it is changing the way that it sees objects like surfaces, single color. It's using a particular base. ISO curve width is already defined. So, be mindful of these changes. I'm going to leave mine on shaded. I still like shaded mode, just to show you another way to visualize geometry. I can define a material. I can create material, which I could feed into this custom preview. And you'll see here it has its own default values of a kind of pinky color. So I want to change this to being the green again. That's my diffuse color. And I can change things like transparency and shine. So there's also another interesting thing here called specular. Specular allows you to add a degree of shininess, color shininess to your object. So we'll see it pop up in a second. The first thing I want to do is change my shine value from 1 to 100. And it should be getting more shiny. What we'll do is we'll just change mode to maybe wireframe. And we'll see that now, shininess change in that object, which may or may not help you see things a little better. And I can change my specular color to being something completely different. What is its shininess? So just some fun things to do inside of Grasshopper to preview things a little differently. So this is, again, just a way to visualize the geometry a little different using custom preview. And you'll notice here this little red bar, this is the profiler. So under display, widgets, profiler. This is telling you how long this task took to calculate. 5 milliseconds. The reason I want you guys to work with the profiler is because later when you start making heavier geometry, I want to get you to think about ways of shortening your time on some of these. All right. Let's go ahead and continue on with one more way to visualize things that may be handy for landscape. which is the contour operation. The contour command, or component rather, says give me a shape, give me a starting point, a direction, and a distance. In this case, I'm going to move everything down just to get it some more distance. I'm going to put it up here. I'm going to give this my shape. My point, I don't really need to change my point. It's 0, 0, 0. That's going to work fine. The direction, you can see if I hover over it, the vector that's defining the normal direction, it's a vector, is 0, 0, 1. This means it's going positive in the Z direction. So X is the first number, Y the second, Z the last. So it's going positive in the Z direction. And distance, I just want to say, what's the distance value of my contours? I can create another number slider, perhaps starting with 0.25 meters and going up to 1 meter. And I can plug that into here, and it's making my contours. Now, again, it's making the contours the generic green and red. So if I really wanted to get fancy, I could make another custom preview. This is the geometry I want to change. And I make a new swatch. And maybe I want to make my contours white. Let's move this over here to keep things clean. I'll turn this off so that I'm only seeing this result. So now I have added on some specular shine. I can change that however I like. I can decrease the shininess, or I could increase it. I could even make this a little transparent if I wanted with some values. Oh, here it even tells you a little hint. 0 is opaque and 1.0 is transparent. So I would need to change this to being a real value that goes from 0 to 1. And we'll just call this. Okay. And there you can see it a little better. So just some fun ways to visualize some of these elements. If I don't like any of this, I can obviously just disconnect it and disconnect it and disconnect it. And I just get, again, my diffuse color, which may be more advantageous to me. So just some ways to visualize and work with this stuff here. Now, this is bringing up something kind of interesting. Thus far, all of the data lines have been single lines. Again, that's happening through draw fancy wires. I want to draw fancy wires on. Because coming out of my contours, you'll notice that I have a dashed line. A dashed line in language of Grasshopper denotes that there is a list of information. This sounds more complex than it is. But this raises the point of why do I want to use the panel component? Again, the short form for panel is // Panel allows you to put not only information in, like we saw with the sphere, but also just to see what's coming out. And in here, I've taken the contours and I've fed it into my panel. And I can see that Grasshopper has organized my contours into groupings. Group number 0 has 1 curve on it. Group 1 has 3 curves on it. And I can see that there are 17 groups of curves. For those of you that are following along well, that is happening because there are 17 created contours. And on each of these slices, either they have 1 or 2 or more curves. That's how Grasshopper has interpreted this data of this the structure of information. So it's handy just to have a panel sometimes just to see what's going on under the hood. And I love to use panels for this reason. Now, this may or may not matter for contours. Doesn't really matter for us right now. But if I wanted to, let's say, subdivide this surface and put trees on at specific points, for example, we could do that. And I'm going to do that by moving this down, keeping these together. And now this is my base surface. And I want to find a way to put some type of a sphere, a tree, on top of this landscape. So I'm going to use a command. I'm using NURB surfaces all for now, just to start, because it's just a little easier to visualize. We'll go into meshes very shortly. I want to basically divide my surface. I want to give it a surface, and I want to give it a number of u and v values. In here, you can see out of the box, it is giving me 10 and 10. Great. Now, I want more control over that. So I'm going to make a slider. Pay attention. It wants an integer value. Integers, I can tell it's asking for an integer because of that hexagon symbol with the number 7. If I go here to inputs, I want an integer. That there is a whole number, no decimal points. Again, I'm pulling this down here just to correlate these two things. That's what it's asking for. And I can make a slider that goes from 1 to maybe 30. And I could either give this to the parameter or just go straight to the u and straight to the v. And as this number increases, the points increase. It is dividing the surface into more or less points. Great. So coming out of this are a series of points. And we can take a look at how these points are structured by using a panel. And you can see here that the data has been structured into a series of collection of points. Now, because I have done 19 in this case, I expect to see 0 being 1, a placeholder for 1, all the way to 18. Sorry, in this case, actually, it's making 19, which equals 20. Now, the reason that this happens is because when you're dividing a surface, it's going to start with 1 automatically, and it's going to make a division all along. So I want 19. I'll make this actually a little easier to see. Let's actually go to 5. I want to divide the surface 5 times. Here's 1 division, 2, 3, 4, and 5. But notice it has made 6, 1, 2, 3, 4, 5, 6 rows and columns of points. That's why here we have 1, 2, 3, 4, 5, 6. From 0 to 5 is 6 slots, and it has organized them into these categories. We have here a total of 6 slots of information, each with 6 slots of points. That's what this double dashed line under display draw fancy wires is indicating. I love to keep draw fancy wires on because it tells me how that data is structured. Great. Now I have some parametric control over quantity of points. And if I wanted to put a tree at any one of these points, I could do a couple things. I could say, I want a list item. I want to effectively call out one of those points. So I'm going to go, and it's not easily found here, list, oops, I can spell it helps, list item. Here it is. This is my list of values. It's asking for an index. What number do you want to call up? And I have, in this set of points here, I have 81 points. So I'm going to make a slider that goes from 0 to 80. And I'm going to call out, you can see here, what I'm going to do is make a custom preview just so that you can see it a little better. Here's the bubblegum pink item that's being pulled out. And you can see here what's happening. I only wanted 1 point, but it's giving me a row of points. This is because the data has been structured as each row of points is being made. Now, sometimes data structure is handy. Sometimes we want a whole row. Sometimes we might want a column, and I'll show you how to set that up in a second. But in this case, I just want 1 point, just one, and I want to put something on that 1 point. So in this case, the structure of the data is not handy. It's actually causing a problem. So there's 2 ways to go about this. One is we can get rid of the data structure. So I could pull my points into a point container and feed that into my list. And I can right-click on this and I can flatten the data coming in. Flattened data means it no longer has that structure. Let's just see, then compare. Here's the data coming from my point that has been flattened. And here's the data from my structured one. Notice here, I have these collections of these containers of points. It's been organized into rows. Here, there is no structure. Now, if I were to go along here, here's my bubblegum pink. Let me just turn this off so that it's more obvious. There's my bubblegum. Well, maybe I'll leave this one on. There's my red points, and there's the bubblegum pink one. You can see it kind of right there. Now, when I use my slider, you can see that it is selecting points all the way from 0, the beginning one, and it'll keep going until it reaches the end of 80. Now, from that 1 point, I could put, if I wanted, I'm just going to get rid of these panels, and I want to use the stuff we used before. I'm just going to construct a plane and take this and move this over here, because I want to make spheres at these origin points. And I'm going to turn these on and turn this on, enabling it. And here now it is going to make a sphere at whatever point I have said it should go. Now it's making a sphere right on the centroid, and we can talk about ways of moving that, but I'm just showing you how we went from data structure to removing data structure to calling specific data points and using those data points to make more geometry. And of course, we can still change its diameter. So let's actually pause this for now. I'm just going to turn the preview off because, maybe, hypothetically, I just want to make, I want to make a row of trees or maybe a column of trees. And so this list of points that has been flattened is maybe not so handy. So how, again, this is the way that my data is structured. It is organized into these collections. How would I be able to access, instead of a row, let's go here. I want to access, yeah, let's access a row from 0 to 10. And I'm going to move these further down out of the way so that we can just see what we're looking at here. So let me just turn this preview off. And I'm going to put a point parameter here. And I'm going to custom preview so that it's easy to see. In this case, with the pink bubblegum row. So now I can call out a specific row of points. Maybe that is something I want. What if I wanted a column? This is where data structure is also interesting. Here, what I could do is use a component called flip matrix. Flip matrix basically converts data from one orientation to another orientation, as you can kind of see here. So instead of organizing my points into rows, it will organize it in this case into columns. And I want that data to happen up here. So I want my list of points from rows to be turned into columns. And I want to use that data to then call out my row. So you can see here, I've changed it from rows to columns. And I want to put trees on this row. Great, I could do that. But maybe I want to put, trees on every other point. And maybe the trees are going to be too big. Here, I can use something called a cull pattern, which is going to, again, work with list. It's like, give me a list of data, and then give me a pattern. In this case, the pattern is by virtue of some true and false values. Here you can see, where is it showing this? Just turn some of these previews off because it's starting to get a little messy. And I'm going to make a value here of true, false, and feed that into my cull pattern. And we have a red icon. What has happened here? We failed to convert text to Boolean. So what we need to do here is we could actually get rid of this, and we could go to the set multiple Booleans. I'm gonna change this. True, true, to false, true, commit changes, and I should see a value come out on the other side, but I'm not. 1 second. Ah, yes. Okay. What has happened here is that I have data coming in, and I want to call out a specific row. Again, we'll just highlight that. There's that row. And I want to be able to say, hey, for every of these items, I want you to be a true or a false. But what's happening in here is that I am getting basically nothing inside of this because the data is still structured into some categories. So what I want to do now is to simplify the geometry coming in to see if that helps, and it's not. Simplify, you can tell what has happened here. If I take away simplify, the structure is staying the same of 0, 0, 2, 0, 0, 3. Simplify just reduces it to the one number that actually has agency, 0, 1, 2, 3, 4, 5. So here it's not helpful. But what I want to do here now is flatten the data. I don't want any structure. I want this cull pattern to say, hey, the first one is true, keep it. The second one is false, get rid of it. This third one is true, keep it. And now my list of points is reduced from 9 to 8 in a stagger stop orientation. So I'm just showing you here how data is organized. This is just to show you some examples of how you need to be mindful of your wire types, because you can see here a single line, one piece of data. A double line means there's a list of data. There's a list of multiple pieces of data, but only one reference. And a dashed line means I have a list of multiple subcategories to consider. That's all I want to highlight with this little exercise here. Of course, we could do what we wanted to do in the end, which was I want to put a sphere. I want to put the spheres at all of these points. And I want to change its radius from 1 meter to 3 meters in whole numbers. There we go. And it's not very handy because the spheres are right inside. So I need to actually move this list of points in the z-axis, which is what it gives us automatically, but it pushes it up by a value of 10. You can see 0, 0, 10. So I actually want to make a z vector that I define with a slider that goes from 0.5 meters to 5 meters. And I can now change this value. You can see those points raising. And it's these points that I want to make. And I want to make bubblegum pink trees. Maybe they're not really trees. Maybe there's some sort of shade or something. But I now have the ability to change their diameter, radius rather, and their position. I could always go back here and say, hey, I want to actually change a different row. Or maybe I actually want to work with, instead of columns, rows instead. And instead of this cull pattern being this way, I want to change my values from being false, true to false, true, true, and see that I can get pairs of trees. And I can go all the way back to the beginning and I can say, please divide this up into more points so that I get more trees to work with. So I know we made a little bit of a mess here, and it was all basically to describe how to A, reference in a surface, change that surface inside of Rhino. I'm just going to turn everything here off. And I want to go back to my underlying surface. And if I don't like it, I could always type SES again and add more variation to it. And now that surface, I'll turn it off. I'll turn it off here. I'll preview it here just for fun to see what it looks like. And I can see what the trees that we made look like on top of there. So quick review, we learned how to talk to Rhino by either referencing in geometry volatile data or talk to it by turning visualizations on or off. We've talked about parameters, which are containers of information, versus components with which do something. We've talked about data types, which are these lines. Single lines is one piece of information. Double line is a list of information. Dashed lines are lists of information. We've talked about how to visualize things in a more unique way with custom preview, create material, which can even work on things like lines. We've talked about flipping data versus keeping data the same. We've talked about how to remove data structure versus keeping it. And we started to introduce some aspects of movement and vectors, as well as patterns of working with data. So all of this is to say, these are some of the basic underlying features we will use for the rest of this course. So I would like you all to just get familiar with this kind of work on your own and start playing with it. And I'm going to take a quick pause here for now. And we're back. So the last thing I wanted to highlight before moving on is basically just to add more notes around cleanliness and organization of your script, because you can already see here things are starting to get maybe a little confusing or messy, and it may be handy to delineate things graphically in a different way. The way that we can do that is twofold. The first is obviously you can use things like Snapping Gecko to keep things a little more clean and organized if you need to, kind of like how I'm doing it here. And that's great to just get them into more organized clusters so that you're not having to have your eye move around too much. But there are other ways to further enhance this. So what you're seeing me do here in real time is just kind of clean this up as best as I can, pulling parameters that are going to affect things together into similar areas, and maybe even adding some relays to keep things extra clean when I can. Here, I'll just move this data over. Here now, all my parameters are kept the same, just being extra clean when I can. And so in this case, this grouping of components is what's making my rows of trees. And so I may want to Control G to actually group these guys together so that I don't have to move each of these things individually. So again, all that happened there, I'm just going to delete this. I've used a crossing window to select them all and hit Control G to turn it into a group. You can tell it's a group because it has the purple background, and I can move it collectively. I can then right click on anywhere in the void of the group and have a name here and say tree making cluster. And so now I know when I move this around, hey, these things make my trees. Great. I can also create text. Oh no, not text here. What I actually want to do is what is the element I'm trying to get here? Name, property name. I'm forgetting text. There's a way to add text here, and I'm forgetting if it's one of these components that may be the case. I think I could add text in a certain way. In any case, there's a way to add text. I'll find it for you. I'm just blanking in the moment right now. But you can add things like text, like large blocky words, which is super helpful to doing things like this. But grouping is the main idea. So this here was to put down one tree. So I'll just organize my components together this way, group it together and say one tree placement versus tree making cluster. This is for my contours. And this, I don't need this anymore. This is for my points. And this is my and now you can see actually the script is much more manageable. It is much easier to see what's going on. I can be like, hey, I want to make contours here. Here I can make trees, clusters of trees versus singular one tree. And now instead of thousands of components, not thousands, but dozens of components, it looks like I only have 5 things. Much easier to follow along. So to advance us to the next things, I wanted to point your attention to what you can find inside of the FTP. Inside the FTP, you will find a technical folder which has a series of experiments in it. So again, I'm just going to go up. There's a series of experiments, and there is a rough folder, a surface folder, and a populations folder. Inside of the rough folder is going to be for me to put some sketches down. You probably don't need this. You will want to look at surface and populations. Let me show you what is inside of these. Here is another instance of Rhino. I'm going to again dock my Rhino to the left and dock my Grasshopper to the right. Inside of this FTP folder, we'll go to surface first. There is, the way that it's broken down here is you can see there is a code at the beginning. The way to read this is surface generator number 1. I've emulated what's coming from Parametric Design for Landscape Architecture, Chapter 2, and it's making a surface generator. Inside of each of these is a Rhino file, and in some cases, a corresponding Grasshopper file, and you can see effects that have changed in your little preview here. Now, for us, I just pulled up the very first one. Let me just open the right one. Surface generator from Parametric Design for Landscape Architecture, Chapter 2, Subsection 3, pages 51 to 61. So I'm just going to open this file up. And I have the right corresponding Grasshopper file here. The little asterisk means, hey, something has changed, and you need to save it in order to acknowledge that change. Just FYI. Now, the way that these files are organized is that I have delineated a little header here that says it's coming from our studio, that there is dependencies of the Rhino files. So in order for this to work, it needs the Rhino file. I remind you that turning on your bifocals is pretty key. And for our generative design studies, you want to turn your profiler on in order to see the performance of some of this work. So profiler here. And I reference which pages from the book I have emulated here. So what you're seeing here is in the Rhino file, a very simple file that has essentially just, let me just curtail this, just a 50 by 50 meter surface that we're going to use for some topography or landforming. You will notice some files in here, such as a reference NURBS surface, kind of the same way that we did things, and a couple of other layers that are there preemptively. Now, what I've done is I've actually taken what you would see in the book, and what I can do is actually pull that book up here so that we're all on the same page. I will go, this is a slightly different directory, but yours will see the same. I'll go to readings, and I will go to parametric design for landscape architecture. Here is this PDF. And I am referencing here pages 53 to 61 of the PDF file, chapter 2. So I can go here and just, I'll make this super big for now. Just shrink this down. And I will go to page, just follow along here and go to page 251 to base topography. I think it's 0205. So here, this is morphing geometry on a surface to create a field condition, starting with a surface, subdividing it. I've basically done what this person is saying in many cases, and then just rebuilding it for you with metric values in mind, and the fact that you can actually see some of this for yourself with annotation. So I've added notes to each of these to try to describe a little bit more what's going on. So in this case, I'll just walk you through this. I also have up here at the top what I call pseudocode. Pseudocode is basically the description of what you want to do in plain English. The dark blue is my overall ambition, and then the light blue are ways that we can achieve this in subtasks. And then finally, I have a little challenge statement for you if you want to push yourself. But the intent of these files is that you would read through them, you would play with them, you would break them, you would try different things as you were getting used to this. So in this case, I want to achieve having a point that a designer or a genetic algorithm can move around that will reshape a surface. So to do that, I need to reference in a base surface divided into lots of points, reference that one control point that will be used to reference other points from A, using an operation to measure the distance of this one point to the other points, and then remapping those distance values to a new domain and pushing my values in the z-axis relative to that distance. Maybe it sounds a little complex, so we're gonna walk through it. Here is my referenced in surface from Rhino. I just set one surface there. I then divided this surface up into lots of points, 37 sections, which equals 38 rows and 38 columns of points. I have a control point here, a point that I drew in Rhino that I can move around and it will stay updated. I'll just turn that off for a second. And I have a closest point calculator. This component comes from the vector ribbon tab under points. And what it says is, give me a set of points and give me something to react to, a cloud in this case. These can be reversed for different reasons. I'll show you when and where to do that. But for now, it's basically measuring this one point versus all of these other points. And I have a distance value that's coming out of it. So it's like, hey, from all of these points, the distance from it to this one, to that one, to that one, to that one, to all of them is cataloged here. All 1,443 points have been calculated, their distance to this object, this reference point. I'm just going to turn this off and say, hey, that's great. This number that you have, I'm going to use that to make a boundary. I want Grasshopper to give me the lowest value and the highest value. So we can actually just preview that, and we can see that at the lowest end, the point can be as close as 0.8 meters to 54 meters away. The reason that I want a boundary is because I want to take these distance values and I want to push the points up in the z-axis relative to that distance. So it's going to act like an attractor point, if you guys are already familiar with that term. Meaning, if I move this point around, it has a sort of magnetic attractor effect on something. And in this case, the something is making the z values of the topography go higher or lower. So let's just take a quick peek at the end here as to what is happening. Here is my surface, my topography. And as I move this point around, it is changing the topography. I'm just going to turn off some of these other curves here. Where is my reference control point? There it is. Now you can see as I move this point around, it creates a different topo effect, and I'm slicing it up using the contour command to visualize it with a custom preview. So how did I get that to happen? Again, I have a closest point. It's measuring its relationship to all the other points, has a list of values, and I'm saying, hey, that domain from 0.8 to 54 meters, that's all the values you can have. But I want you to remap those numbers. I want you to take all those values and actually constrain it between 0 meters and 10 meters. That's what this source is. It's saying, give me all the low and high, and then give me a new target. In this case, 0 and 10. Now I could change this. I could make it a lot less heavy. I can say, you know, the high value should be 7.5, and the low value should actually be higher or lower. So I'm parametrically controlling the remapping of these numbers. And then I'm using these values to get new values. So all of these versions here, you can see 34.016052 turns into 5.03 blah, blah, blah points. The second number of 33 turns into 4.9. And I'm using these numbers to make z-axis vectors to push my points, my original set of points here. I want to push them all up by this value. You can see these points here remapped on. And in this case, I'm using a surface again. I could actually just use a Delani mesh. Here's all my points. Flatten said set of points. And let me just turn these guys off so you can see it's effectively creating the same thing. It's a little hard to see, and this is a great time to call up how to visualize meshes inside of Grasshopper. Meshes, perhaps in your situation, out of the box, you do not see the vertices or the edges, like mine right now. The way to turn meshes and vertices on and off is inside of your Grasshopper canvas anywhere, type Control M. And now you can see the underlying topology of how all those points, again, those are those points, have been interpreted into a structure for a mesh. And as I move this point around, you can see it is changing that topography. Now, of course, I could feed this mesh into my geometry here for preview. Oops, here for preview. And I actually want to use this mesh to be sliced up and contoured. So I'm just going to turn these guys on. Yeah, sorry. My contours is what I want as black and white, black swatch here. And the mesh I want itself as this kind of pale green. So it has almost the same effect as constructing a surface from points, almost the same. The resolution can be changed on some of these, etc. I'll show you how. But basically, this is giving you a description of how this author from Parametric Design for Landscape Architecture has conducted his work. Oh, and here I can go to 53. Yeah, here we go. Constructing a mesh from moved vertices. So basically the same thing that you're seeing here. So why do I bother introducing this stuff to you guys? Let me just Control Z a couple of these to get back to the surface so that it emulates the book exactly before I share the file with you. The reason that I'm sharing some of these examples from this book, Parametric Design for Landscape Architecture, is that they are doing from first principles what will happen in LandKit. So LandKit is, I'm going to talk about it in a second, but it comes with these 4 different kits: plant kit, land topo kit, water kit, and paving kit. And topo kit works very much by doing this same process. You have a set of points. You have a set of points to start, or other features. They will get turned into points. They will make a mesh of some kind. You could use attractors to change values of objects to push points up or down. Those changes get remapped on and finally turned into a new surface or surface. Remember, I can say NURB surface or mesh surface. So you're taking an initial surface, breaking it down into points, doing something with those points, and then just remaking the surface, whether it's a NURB surface or a mesh surface, and then visualizing it downstream. That's why these first principles book is quite useful, because later down the line in TopoKit, you may be wondering, how do any of these tools work? This is how they work. It's this points of remapping them and making a new surface that works. So I'm going to take a quick pause here and I'll just introduce LandKit. Okay, let's talk about where we are in this deck, because it may be helpful to zoom out here. We did a grasshopper grasshopper level set where we talked about the canvas, menus, widgets, etc., navigation, right mouse button, left mouse button difference, talking with Rhino. We did specifically a follow me. We talked about components versus parameters, double clicking to search for things, data flow, data types, panels, cleanliness, grouping, pseudocode. Remember to think about your synthetic working sheet. We covered plugins. We did a follow me, a reminder about food for Rhino, and the package manager. And now we're going to talk about LandKit. The reason why we are using LandKit is because we don't need to do everything from first principles. In the same way that I described the sample from before, of course, you could do this if you wanted. You could do a series of these ways to modify, generate topography all on your own. And it is very much possible. There is no rocket science behind LandKit. LandKit simply makes things a lot more convenient to start with. So LandKit Pro comes with 4 kits, as we've already mentioned. Topo Kit, which can build and modify, shade, analyze, and document topography with meshes only. It can have a water kit, mostly water-based hydrology analysis, again, only on a mesh. It can manage, reference, allocate, analyze, pattern different plants to go onto a given environment and mesh. And then a paving kit, which can create these cool patterns for paving elements, etc. Now, to get access to LandKit, there's a couple of ways of doing it. You could go through Food for Rhino if you want. Remember to get LandKit 1.2 from earlier this year. Or you could go through your package manager, land_kit, and you could install it. Remember to refresh your Rhino and Grasshopper after you install it to see it. And out of the box, you will notice that all of the 4 kits should be installed. That would be plant kit, topo kit, water kit, and paving kit. And to get access, again, what you'll notice is that some components have a little red square graphically on their upper right. These components are only available in the professional version. You have access to the professional version through Rob, through a class lab license. To get access to that lab license, to unlock your pro version, you need to go to the paving kit, all on the far right, the purple one. And there's an info bar here that has the info land kit license. When you double click on this or enable it or drag it onto your canvas, automatically a little LandKit Pro key will pop up and says, hey, your current key is, probably for you, it's going to be blank. If you've already gone ahead, cool. You want to input this key here. This is our lab license key for this class. Once you input it, you're going to update the original. So update. And you should now have access to all of the red icon-based components. So some of those red icon components are things like modifiers to topography, which for us, we will use as generators when we modify topography as need be. There are also some great red ones for analysis and drawing. And I'm just showing you here a little bit about what we will do with TopoKit. I'll just move that away in case it's blocking it. Some other tools that are handy, things like shading, kind of handy. and drawing kind of handy as well. Maybe we can leverage it with our artificial intelligence, artificial neural network, latent diffusion rendering. But just keep in mind that we're not going to use everything from LandKit or any of the subkits like TopoKit. We'll use some pieces of it. So the reason that I bring this up is because inside of your FTP, there will also be a series of under experiments, technical folder, there is some surface generators that are specific to LandKit and to TopoKit, or inside of populations, almost all of our stuff comes from PlantKit, from LandKit, PlantKit. Many of these are scrubbed from the directory that I've given you on LandKit and Campus Plus. So you can see TopoKit. These are all the videos that have been referred to. And whenever I have a little plus file here, I've made for you new files that are inside your FTP directory, because the reason is that all of these sample files were built in Imperial and are based on plant lists and other documentation that is specific to America. And I wanted to make sure that these were rebuilt for you with metric in mind, local plants when possible, and more documentation and annotation. You'll notice inside of these participant packages that the files are, they can get pretty messy. So that's the reason I'm showing you this today, just as a simple thing. So for now, I hope that this technical introduction was exciting and handy and useful. Your goal for Tuesday is to start going through the experiments under surface, the first principal ones, like parametric design for landscape architecture, maybe even some of these, where you can just start to play with them and start to generate some experiments of your own, not surfaces, just rough sketches, even if you just want to mess around a little bit. I want to see on Tuesday that you guys have started to play with Grasshopper and can start just doing simple things, whether it's drawing circles or making things that correlate to one another or subdividing a surface. Your goal is to just start playing. Just start getting used to this. So I'm going to stop here for today on parametric and performance modeling for now. Thank you.